Okay, this is number 24 in our first set of application problems in intermediate algebra. It says Chance leaves the truck stop at noon. On a bicycle traveling west at a rate of 15 miles per hour, at 12:30 p.m., Aaron leaves the same truck stop in a car traveling in the same direction at a rate of 60 miles per hour. How many hours will it take Aaron to catch Chance? Let's draw a picture. So let's say that this happens to be, well, I always forget to convert my pen over. Let's say this happens to be the path that they're traveling on, and we'll say that over here is the truck stop. Okay? Chance, he's driving, or he's riding a red bicycle. So let's say here it is. Chance is traveling on his path, and he leaves at noontime, and at 12:30, Aaron is going to leave the same truck stop, and at some point in time, they're both going to pass each other. Okay, now if you've noticed here that the distance that they travel is the same, their distance is equal, okay, but the amount of time that they spend on the road is definitely not. So let's go ahead and write out, this is going to be the equation that we're going to be using. Distance is equal to rate times time. Okay, distance is equal to rate times time. Let's write the distance for the equation for Aaron. So Aaron, the distance Aaron travels is equal to, he's going 60 miles per hour, and we'll say that he travels in some time t. Right? The amount of time, we'll just call it t. The distance that Chance travels is equal to, he's going 15 miles per hour. Now the thing about Chance is he's going to leave a half hour earlier, so he has a half hour added to the amount of time that he spent traveling. See that? So this is the tricky part right here. Okay? Alright, since they both traveled the same distance, we know that these two are equal. Alright, those two are equal, which means that we can set these equations equal to each other. And simply solve for t. So 60 times t is equal to, let's distribute this 15 across, so that becomes 15t plus 15 times a half is just, we'll leave it at 15 over 2 here. Okay. Now we'll want to take this 15t over, and so this becomes 60t minus 15t is equal to 15 over 2. These are both like terms, so 60 minus 15 is going to give us, 45t. And that's equal to 15 over 2. And what we'll do now is multiply both sides by the reciprocal of 45, so that leaves us with t is equal to 15 over, what is that, 90? You're just taking this 45 and multiplying it by 2, bringing it diagonally down. So 45 times 2 is 90. Alright, and we can, let's just approximate this right here. It will simplify down, but we're going to say that it's 1. Let's go ahead and leave it to 3 decimal places. Okay, But that fraction simplifies down to 1/6 if you want to keep it like that. And because t is in hours, ooh, excuse me, I didn't have a chance to pause the video. That came out of nowhere. Alright, so 0.167 hours, which, if you would like, we can just convert that to minutes. So multiply that by minutes, and wait a minute. I'm getting 10 minutes. What in the world? Yeah. 0.167 hours. So as you can see here, it says how many hours will it take Aaron to catch Chance? Well, it only took him 10 minutes, actually, or 1/6 of an hour to actually catch Chance. Now, if you were wanting to know, well, how long has Chance been traveling, what you would do is take that t and add it to that half of hour, which is 30, looks like 40 minutes. So it doesn't even seem possible, if he had a 30-minute head start, that it would only take him 10 minutes to catch him, but he's traveling at 60 miles per hour. So we just got to trust the math on this. Now, let me say something about this problem. If you happen to get the relationship mixed up, and you happen to add a half an hour to Aaron's time, instead of, you got these two mixed around, what's going to happen is when you're solving for t in the problem, you're going to end up getting a negative number. Okay, so that's when you know that that you've done something wrong. You get a negative number like that. All right, you see. So, all right, well, check it out. Try that out sometime. We got another distance problem coming up here in the next problem. I'm trying to remember what problem. Yep, it's the next one. This is a little bit more difficult of a problem. All right, see you there.